Hello. Today our class is on mean deviation. Okay. First we'll discuss about what is mean deviation, how it is. Um, Earlier we have discussed range and quartile deviation for measuring dispersion. The chief limitation of these two methods is that their calculation is not based on all the values, and to overcome this problem, other method of dispersion which are based on all the values are used. Okay, that is mean deviation and standard deviation will overcome this problem. Uh, what is actually what is mean deviation? Mean deviation is also termed as average deviation. Is defined as the absolute average of the deviation taken from measures of central tendency. Okay. In the words of Clark and Shaker, average deviation is the average amount of scatter of items in distribution from either mean or median, ignoring the signs of deviation. Okay. Though deviations can be taken from any measure of central tendency, that is arithmetic mean, median, mode, are generally used. Okay. Mean is preferred because it is algebraically sound. Okay. Theoretically, median is considered appropriate as the sum of deviations in minimum when plus or minus signs ignored. Mode is not very widely used because it is difficult to define the modal value in all distributions. Sometimes mode is ill defined. We have seen okay how sometimes multimodal okay situations also arouse, right. Then mode is not very widely used, okay, because it is difficult to define the modal value in all distributions. Okay. In practice, however, arithmetic mean is the most commonly used average. This is the reason why the measure is called mean deviation. Okay, why we are calling it as mean deviation? Because of usage of arithmetic mean in most of the circumstances, right? Then for calculation of mean deviation, the algebraic signs plus or minus are to be ignored because if the signs are taken into consideration, the sum of deviations from mean will be 0. Okay, and the sum of deviations from the median and mode will be nearly 0. Of course, they may not be 0 but nearly 0. Hence, we are ignoring the algebraic signs, that is plus or minus, right. Mean deviation is obtained by dividing the sum of absolute deviations taken from the average by the total number of observations. Okay. Generally, the symbol modulus we say mod. Okay, in mathematical we say that mod. Some people say that modulus denotes the deviations taken by Green's algebraic signs. Okay, two straight lines, perpendicular lines. In between two perpendicular lines, we will keep the deviation symbol, that is called modulus. Two perpendicular symbols, okay, called as modulus. The formula mean deviation, when the deviations are measured from arithmetic mean, okay, formulas will be different. This is a md x bar we have taken. X bar shows that it's mean deviation. mdx we have taken there, mean deviation from arithmetic mean, that is mean deviation from mean, which is equal to summation of, that is big sigma. Okay, and the two lines which are on dx, here dx bar we have taken. Okay, the two lines which are slant somewhat, they are nearly perpendicular in modulus. Okay, they are called modulus or mod. That means the signs are ignored. Modulus says that we are not considering the signs, right. Here md x bar is equal to mean deviation from mean. Okay, sigma modulus dx, okay, is equal to dx bar is equal to sum of the deviations measured from mean, ignoring the plus or minus signs. Plus or minus signs, when we say we are applying mod or modulus, we are ignoring the algebraic signs. Okay, n is equal to total number of observations. When mean deviation from median, the formula is changed. Okay, that is md median is equal to summation of D median, that is deviations taken from median, okay, modulus by n, okay, where mean deviation from median, MD median is nothing but median, okay, and sigma, okay, modulus D median is equal to sum of the deviations taken from median, ignoring the signs, okay, that is plus or minus signs, right? N is the total number of observations. N is the total number of observations, right? Next, we have when we calculate mean deviation from mod. Okay, what would be the formula? We will see now, right? Formula for mean deviation, right? When mode is taken, uh, deviations taken from mode, MDZ we call it, right? MDZ where, okay, is equal summation of, okay, modulus DZ, that is deviations taken from mode by n, okay, where MDZ is equal to mean deviation from mode, okay, summation of modulus dz is equal to sum of deviations measured from mode ignoring the plus or minus signs, and n is equal to total number of observations, okay, right. Here mean deviation computed with the help of, okay, these formulas in absolute measure. In, okay, formula is an absolute measure. The relative measures of mean deviation is called coefficient of mean deviation. It is computed by dividing the mean deviation by the average used in measuring such deviations. Okay, if we are using mean for the purpose of calculation of mean deviation, okay, if we divide the mean deviation by the average, okay, that is arithmetic mean, we will get the coefficient of mean deviation. If we are using median to calculate the mean deviation, we are, okay, then mean deviation divided by median will give the coefficient of mean deviation. If we use mode to calculate the mean deviation, then mean deviation divided by the mode gives us coefficient of mean deviation. Okay, when arithmetic mean is used to calculate the mean deviation, okay, coefficient of mean deviation will become coefficient of mean deviation and is equal to MD x bar, that means mean deviation from arithmetic mean by x bar, that is arithmetic mean, okay, where MD x bar is equal to mean deviation from mean and x bar is equal to arithmetic mean. When median is used, the formula is different, that is coefficient of mean deviation, okay, of median is equal to mean deviation taken from median by median, okay, where MD median is equal to mean deviation median, and when mode is used for the calculation of mean deviation, coefficient of mean deviation from mode is equal to mean deviation mode by mode, okay, where MD mean deviation from mode is equal to MDZ is equal to mean deviation from mode, Z is equal to mode, okay, where Z is equal to mode. Now calculation of mean deviation by using direct method for individual series. Okay, the procedure involved in the calculation of mean deviation in individual, discrete and continuous series, both direct method and shortcut method are used. Okay, first we will see direct method for individual series. Okay, procedure for this. Arrange the observations in ascending order, okay, or descending order if median is used. Calculate the average to be used to take deviations, okay, and measure the deviations from the average selected ignoring the plus or minus, and obtain the sum of the deviations, that is sigma summation of mod d, we call it as summation of mod d. Divide the sum of absolute deviations by the number of observations for obtaining mean deviation. Thus the formula is mean deviation is equal to summation of modulus d by n. Okay. Now, fifth one, Okay, and the fifth step is divide the mean deviation by the average used to calculate coefficient of mean deviation. Okay, thus coefficient of mean deviation is equal to mean deviation by the average which is used for the purpose. Right. Next, the calculation of mean deviation. We will see one example for the better understanding of mean deviation from arithmetic. Right. The data is given, okay, relating to hourly output of two workers, x and y. Compute mean deviation and its coefficient using arithmetic mean is given. Okay, and that is x is given that 34, 48, 41, 36, 44, 37, 43, 39, 40, 38, and the y values are 44, 46, 26, 53, 30, 27, 50, 48, 29, 47. Calculation of mean deviation and the coefficient of mean deviation we need to calculate. X worker for first the sum, we will take the sum of those items, that is sigma x, that is 400 for x worker, and sigma y for y workers. Okay, that is also that sum of the y workers total and the sum of the x workers total are equal, that is 400. First we will calculate mean deviation for x workers, that is we need to find out arithmetic mean, that is sigma x by n, 400 by number of observations are 10, hence x bar is equal to 40. Okay, from 35 in order to make deviations, in order to calculate the deviations from x minus, we take x bar is equal to dx bar. Okay, that is x minus dx, 34 minus 40 you will get minus 6, but we are here what we are considering modulus, we are taking modulus. Okay, mod of dx or dx bar or modulus of dx bar, hence we ignore the signs. In that manner we will get 34 minus 46, 48 minus 8, 48 minus 48, 41 minus 41, 36 minus 44, 44 minus 44, 37 minus 43, 43 minus 43, 39 minus 41, 40 minus 40, 0, 38 minus 42. Hence, we have not considered here the algebraic signs because of we are considering here as mod sigma dx bar dash, which is equal to 32 you got. Okay, in the same manner we need to work out for the y workers. Okay, y workers, if you substitute these dx for x workers values, that is mean deviation of x bar, that is equal to summation of dx, okay, dx modulus, dx bar modulus by n, where we know that sigma dx modulus is 32, n is equal to 10. Okay, 32 by 10, that is mean deviation from mean is equal to 32 by 10 is equal to 3.2, and coefficient of mean deviation is equal to mean deviation from mean, that is 3.2 by x bar is equal to 40. 3.2 by 40 is equal to 0.08 is the worker x coefficient of mean deviation, whereas worker y, if you calculate for worker y, okay, worker y, arithmetic mean for worker y is sigma y, that is 400 by number of observations 10. Okay, that is also 40 only. Okay, the y bar is also 40, we are saying for the sake of x bar only. Okay, x bar of y workers is 40. Okay, now we will calculate mean deviation from mean, that is sigma dx bar of y workers is, that is how much sigma dx bar we got 96. We have taken deviation from the arithmetic mean, that is 40 minus 44 minus 44, 46 minus 40, okay, 6, 26 minus 40, 14. In the same manner we got the dx bar, okay, modulus, and sum of the dx modulus is 96. 96 by n, number of observations 10, you will get 9.6 as mean deviation from mean. And now we need to calculate coefficient of mean deviation from mean for y workers, that is we got MDX. Okay, mean deviation from mean is 9.6 by x bar. We know that 40. 9.6 by 40, you will get 0.24. 0.24. If you observe these two values, that is workers x and worker y, since the coefficient of mean deviation of hourly output of X worker is low when compared, here 0.24 is Y worker, whereas 0.08 is the X worker, very low. It is more consistent and less variable. Okay, with the results we can interpret that X worker okay, coefficient of mean deviation is less, hence they are more consistent, okay, and variable, less variable, right. Next we will use shortcut method to calculate the mean deviation. Okay, we'll go through the procedure. Arrange the observation in ascending or descending order when you use the mean deviation, right? Median. And second, calculate the average to be used. Third, find out the sum of observations above the value of average, that is sigma XA, we call it as above the value of average, and below the value of average we will consider it as sigma XB in the distribution. Okay, now count the number of observations having their value above and below the average. Okay, last fifth step, apply the formula to obtain the mean deviation. In order to apply the formula in mean deviation, we have, that is mean deviation is equal to, okay, sum of XA minus sum of XB minus, okay, bracket of NA, okay, that we know that number of observations, minus NB average. Okay, number of observations above the value is considered, above the average is NA, number of observations below the average is NB, we have considered, and X bar by N is the formula. X bar by X bar is nothing but average, where MD is equal to mean deviation, summation of, okay, sigma, sum of XA, we call it as, is equal to sum of the observations above the value of average, sigma XB, sum of the observations below the value of average, okay, and minus NA, number of observations above the average value of average, NB, number of observations above the below the value of average, below the value of average is taken, right. Now we'll consider one problem for the better understanding. Okay, calculation of mean deviation and coefficient of mean deviation from mean and median he has given. We will consider only for the sake of it, right. He has asked to find, that is X series is given. He has given in raw data is given. We have arranged the same in the ascending order. Okay, if you use median also, it won't make any difference, right. Next we have taken as per the serial number, we have arranged that, and see 9, 11, 13, 15, 17, 19, 22, 24, 26, 26, 32 are the observations that are found in the given data series. And X bar, okay, calculation of mean deviation from arithmetic mean, X bar first we need to find out in order to make deviations. X bar is equal to sigma X by N. Sigma X is number of observations, 214. Okay, sigma X is the total number of observations, sum of the observations we call it as, okay, that is sigma X is equal to 14 by N is equal to 11. Okay, 214 by 11, X bar is equal to, that is 19.45. Now mean deviation from mean is equal to sigma XA. Okay, that is, as we know that sum of observations above the value of average. Okay, how many observations are there, sum of the value of the average we need to count, and sigma XB, sum of the average, sum of the observations below the value of the average, and NA, sum of the number of observations above the value of average, and XB is number of observations below the value of average. Okay, here sigma XA, that means sum of the observations above the average value, the value of average XA is equal to 130, Some of the observations below the average value, okay, or xb, that is given sigma xb, okay, that is 84. Now we got 84, and na, that is number of observations below the average value, above the average value, na is equal to 5. Number of observations below the average value, nb is equal to 6. N is equal to 11, we know that. And x bar, that is we have calculated 19.5. Now we need to substitute all these values in the formula, okay, given above. If we substitute mdx, that is mean deviation from mean, is equal to 130 minus 84 minus 5 minus 6, okay, bracket of 19.45 by 11. Then uh, 5 minus 6, you will get minus 1, bracket of, okay, 130 minus 84, you will get 46. Hence 46 minus minus 1 into 19.5. Okay, then 46, okay, minus into minus plus, okay. First we will have minus 1 into 19.45, 19.45 minus, minus into minus plus, hence 46 plus 19.45 by 11 is equal to 65.45 by 11 is equal to 5.95. Then coefficient of mean deviation is equal to md x bar by x bar is equal to, here md x bar is equal to 5.95, x bar is equal to 19.45, right. Substituting the values in the formula of coefficient of md, okay, you will get 5.95 by 19.45, which is equal to 0.306, 0.30. Since the coefficient of mean deviation is low, the distribution is concerned, okay, the distribution is considered as the consistent one, okay, consistent one, right. Okay, calculate mean deviation and coefficient of mean deviation from median. For the same formula, if we use, okay, median is equal to size. Size is n plus 1 by 2th item. We know that. Okay, here number of items are 11. N is equal to 11. We found that, and median size 11 plus 1 by 2th item. Okay, it is wrongly noted. That is 2th item. Then size of 6th item is in the distribution is 19. Okay, that means 11 plus 12 by 2 is equal to 6th item. 6th item in the distribution is 19. We know that. Okay, and now the formula is used. Mean deviation from median is equal to, okay, sigma xa, the sum of the observations above the average value, sum of the observations below the average value, sigma xb. Okay, above the average value is 149, that is sigma xa, sigma xb is 65. Number of observations above the average value is 6, number of observations below the average value is 5, n is equal to 11, and median is 19. Substituting these values in the given formula, we will have 84 minus 19 bracket by 11, that is 65 by 11 is equal to 5.91. Okay, coefficient of mean deviation is equal to, okay, mean deviation taken from median by median, that is 5.91 by 19 is equal to 0.311. Okay, as the coefficient of mean deviation is low, the series is consistent, we can conclude, right. Next, computation of mean deviation and coefficient of mean deviation for discrete series. Procedure is calculate the average from which mean deviation is uh, to be computed. Find out the absolute deviation from the average by ignoring the plus or minus sign, minus signs. And third is multiply each individual deviation by the respective frequency and obtain their total. Fourth is obtain the total of frequencies. Fifth, for obtaining mean deviation, divide the sum of the products of frequencies and absolute deviations by the sum of frequencies. Thus, the formula is sigma f into, okay, modulus d by n. Okay, where sigma f into modulus d, sum of the products of frequencies and absolute deviations. Okay, we call it as n is the sum of the frequencies, or we can say number of observations, but we are using here discrete series, hence we call it as sum of the frequencies, right? And sixth one is for calculating coefficient of mean deviation, divide the mean deviation by the average. Okay, divide the mean deviation by average. And okay, with this we will do one problem on the discrete series. Example we consider, that is, he has given from the following distribution calculate coefficient of mean deviation from mean. He has asked, he has given x and frequency f. X values are 30, 50, 70, 90, 110, 130, 150, 170, 190. Whereas frequency is given that 6, 9, 11, 14, 20, 15, 20, 10, 8, 7. This is sigma f is equal to n is equal to 100. Okay, now what we need to do, fx, we need to solve. That is fx, f into x, 30 into 6, 180, 50 into 9, 450, 70 into 11, 770, 90 into 14, 1260, 110 into 20, 2200, 130 into 15, 1950, 150 into 10, 1500, 170 into 8, 1360, 190 into 7, 1330, which is equal to sigma fx is equal to 11,000. And now sigma modulus dx, okay, that is deviations taken from the average. Okay, sigma mean, in order to find out that mean, okay, what we need to do, we have to consider, we should consider the mean. Okay, in order to find out the mean of a discrete series, we have a formula sigma fx by n. Okay, sigma fx is, we know that sigma fx is given 11,000. We got 11,000 by n is equal to 100. That is x bar is equal to 110. From x bar, if you take the deviations, okay, for x, from the x bar, that means 30 minus 110 is equal to 80. 50 minus 110 is equal to 60, 70 minus 110 is equal to 40, 90 minus 110 is equal to 20. Okay, in the same manner, 110 is equal to 0, 110 minus 110 is equal to 0, 130 minus 110 is equal to 20, 150 minus 110 is equal to 40, 170 minus 110 is equal to 60, 190 minus 110 is equal to 80. These are dx, okay, because mod dx, hence we are ignoring the algebraic signs, we call it as mod dx, modulus dx bar or modulus. Then we need to multiply with what we got, modulus dx, okay, deviations taken from mean, with f of the corresponding frequencies, right? That is 6 into 80 is equal to 480, 99 into 6 is equal to 540, 11 into 40 is equal to 440, 14 into 20 is equal to 280, 20 into 0 is equal to 0, 15 into 20 is equal to 300, 10 into 40 is equal to 400, 8 into 60 is equal to 480, 7 into 80 is equal to 560. If you summate these, okay, sum of these, you will get sigma f modulus dx, f into mod dx, which is equal to mod dx bar, which is equal to 3480. Now find the mean deviation. Okay, in order to find out the mean deviations, we have formula, that is uh, sum of, that is sigma summation of f into modulus dx bar, okay, by n. Here sigma f dx modulus dx bar is equal to 3480 and n is equal to 100. Substituting modulus dx bar is equal to 3000, in order to find out mean deviation, 3480 by 100 is equal to 34.8. Coefficient of MD is equal to mean deviation from mean by mean, which is equal to 34.8 by 110, that is 0.32. Okay, as the coefficient of mean deviation is low, uh, the distribution is more consistent and less variable, right? Now we'll consider discrete series. Okay, for shortcut method, discrete series shortcut method, we'll have procedure for this. Okay, calculate the average to be used. First step. Second step is the find out sum of frequencies, and third step is multiply each value with its frequency and find out the sum of the product above the value of average, that is summation of fxa, and below the value of average, summation of fxb respectively. And the fourth step is obtain the sum of frequencies which are above the value of the average and below the value of the average. Okay, and fifth one, apply the formula, that is md is equal to sigma f xa minus sigma f xb into sigma fa minus sigma fb by fb into average, that is x bar. Okay, by n, where md is equal to mean deviation, sigma fxa is equal to sum of the products of x and its respective frequencies which are above the value of average. Sigma fxb is sum of the products of x and its respective frequencies which are below the value of the average. Sigma fa, sum of the frequencies above the value of the average, and sigma fp, sum of the frequencies below the value of the average. N is the sum of the frequencies. Okay, sum of the frequencies. Now we will do one example on this for better understanding. Calculate mean deviation and coefficient of deviation, coefficient of mean deviation for the data given below. That is, x values are given, f is given. X is equal to, x values are 12, 15, 18, 21, 24, 27, 30, 33 and 36 were given, and f is 8, 12, 14, 26, 32, 36, 18, 9, 2 were given. Okay, if you arrange these in a table form and find fx. Okay, fx, f in multiplied with 8, 12 into 8, 96, 15 into 12, 180, 18 into 14, 252, 21 into 26, 546, 24 into 32, 768, 27 into 36, 972, 30 into 18, 540, 33 into 9, 297, 36 into 2, 72. Sigma f, okay, sigma f, that is summation of frequencies, will give you the n value. N is equal to number of observations or sum of the frequencies, we call it as fx. Okay, sum of the fx, sigma fx we call it as, which is equal to 3722. It is nothing but the product of x and f. Then we need to find the mean. Mean is equal to x bar is equal to sigma fx by n. We know that here sigma fx is equal to 3723 and n is equal to 150. Then that is sum of the frequencies. Now we will introduce the same in the formula x bar to find out. X bar is equal to sigma fx by n, that is 3723 by 157 is equal to 23.71. Now we need to find out mdx, mean deviation from mean, which is equal to sigma fx a minus sigma fx b into sigma fa minus sigma fb into x bar by n. Then we need to substitute the values in this formula. As we know that sigma f x a, the okay, sum of the observations, product of x f into sum of the observations above the average value, that is 2649, whereas below the average value, that is sigma fxb is 1074, and number of observations above the value are sigma fa, that is 97. Number of values, that is sum of the frequencies, we call it as, below average is 97, above average is 97, below average is 60, that is sigma fb. Then number of observations is equal to 157, x bar is equal to 23.71. These values we need to substitute in the formula. Substituting in the formula, we will get 2649 minus 1074 minus 97 minus 60 into 23.71 by 157. Okay, this is equal to 1575 minus 37. Okay, when you subtract 97 minus 60, you will get 37. Okay, minus into 37 into 23.71 by 157. 1575 minus 37 into 23.71, which is equal to 877.27. Okay, by 157. Okay, then 877.27 by 157. Okay, uh, you will get something, that is, you got here is 4.44. Okay, if you solve this, you will get 4.44. That is 1575 minus 877.27. Okay, after subtracting, you will get some figure. That is, if you divide the same with by 157, you will get 4.44. Okay, right now we need to calculate coefficient of MD, mean deviation, is equal to mean deviation from mean by mean, arithmetic mean. Here mean deviation from mean is 4.44 and mean is 23.71. Substituting coefficient of MD values, that is 4.44 by 23.71, you will get 0.187. As the coefficient of mean deviation is low, okay, the distribution is highly consistent. We can conclude that with the result. We can okay, conclude that the okay, while seeing very less, the coefficient of mean deviation is very less, and with that we conclude the distribution is low variant. Okay, deviation is low, that is variation is low, and highly consistent. Okay, distribution is highly consistent. We can conclude with this. Next, mean deviation and coefficient of mean deviation of continuous series. Okay, to find out mean deviation and coefficient of mean deviation for continuous series, we have a procedure. Okay, we have two direct and shortcut method for this also. First, we will go through the procedure. Okay, obtain the mid value of each class. This is first step. Second is calculate the average and take the absolute deviation of the mid value from the average. Okay, and third is multiply each individual absolute deviation with the respective frequencies. That is f into mod d, modulus d, we call it as d. Okay, and get their total as sigma f modulus d. Okay, and to obtain mean deviation, divide the sum of the products, okay, of frequencies and absolute deviations by sum of the frequencies. Okay, that is sigma f into modulus t, okay, by n. This is the formula which we got. This is the fourth step. To obtain mean deviation, divide the sum of the products of frequencies and absolute deviations by the sum of the frequencies. Thus the formula is summation of f into modulus d by n, where summation of f into modulus d is equal to sum of the products of frequencies of and the absolute deviations. N is equal to sum of the frequencies. And fifth step is coefficient of mean deviation can be obtained, okay, by dividing the mean deviation by average use. Now, whichever mean average we are using, whether we are using mean, whether we are using median, whether we are using mode, is important. If you use mean, you should use mean only, okay, for finding the coefficient of mean deviation. If you use median, okay, in order to find out the coefficient of mean deviation, you should use median only. If you want to use mode, okay, you have to use mode to find out the coefficient of mean deviation, right? Next, we'll have one problem on this for the better understanding. It asked for calculate mean deviation and coefficient of mean deviation for the following data. Data is class intervals. He has given 0, 10, 10, 20, 20, 30, 30, 40, 40, 50, 50, 60, 60, 70, 70, 80. And mid values. Okay, that means lower limit plus upper limit by 2. If you take lower limit plus upper limit by 2, you will get the mid value. Mid value for the first class is 0 plus 10 by 2, that is 5. Okay, 10 by 2 is nothing but 5. 10 plus 20, 30 by 2 is equal to 15. 20 plus 30, 50 by 2 is equal to 25. 30 plus 40, 70 by 2 is equal to 35. 40 plus 50, 90 plus 2, 90 by 2 is equal to 45. 50 plus 60, 110 by 2 is equal to 55. 60 plus 70, 130 by 2 is equal to 65. 70 plus 80, 120 by 2, sorry, 150 by 2 is equal to 75. Right, next we have the f values are given 2, 3, 4, 2, 4, 6, 8, 1, for respective classes. Then now what we need to do, multiply median value, that is x, with f. You will get fx or fx, right? Median value is how much? Median value is, and that is for first series 5 and f is 2, then fx is equal to f into 2. Second class 15 into 3 45, third 25 into 400, fourth 35 into 2 70, fifth 45 into 4 180, sixth 55 into 6 so 330, sixth 65 into 8 520, seventh 75 into 1 75. These are the effects. Now sigma fx we need to the sum of these products of mid value and frequencies and their respective frequencies, that is sigma fx is called 1330. We need n also, that is sigma f, that is equal to 30, the sum of the frequencies. And now we need to modulus. Dx means frequencies. We need to find out the arithmetic mean, that is arithmetic mean we got here is 1330 by 30. If you substitute this for 44.33, okay, 44.33 from okay, 44.33, if you subtract, you will get that modulus t, right? And sigma f into modulus dx, okay, means from the average, if you subtract, we need to subtract from the average 44.33 minus, in order to get that sigma dx fx, that is okay, here 180 is taken. Okay, right. Here what he has taken is uh, for the sake of convenience, okay, 44.33 is the x bar value, and mdx is mdx, that is sigma fdx, f into dx by n, 520 by number of observations. Okay, sigma fdx is, you got 520, right? 520 520 by 30, that is 17.33. Now mdx value is 17.33 and x bar you got 44.33. If you find, in order to find out coefficient of md, 17.33 by 44.33 is equal to 0.39, right? And the distribution is fairly consistent, as 0.39 is very small, coefficient of mean deviation is low, right? Based on the coefficient of mean deviation, we will conclude the, we will interpret whether it is consistent, the given distribution, or not, right? Here it is very consistent. Next we'll consider calculation of mean deviation and coefficient of mean deviation for continuous series by shortcut method. Okay, we have a procedure for that, and first we will go through the procedure and then we will solve one problem for better understanding. Procedure is, first step is find the mid value of the class, okay, obtain the sum of the frequencies secondly, and third calculate the average to be used, and fourth multiply each mid value with respect to frequency to get fx, and obtain the products above the value of the average and below the value of the average respectively. And fifth one, find out the sum of the frequencies above and below the value of average respectively. Use the formula, okay, that is md, mean deviation, is equal to sigma f sigma m into fa minus sigma m into fb minus into sigma fa minus sigma fb into average, that is x bar by n. Here we know that sigma m into fa is nothing but sum of the products of the mid values and frequencies which are above the value of the average, and sigma f mfb is equal to sum of the products of the mid values and frequencies which are below the value of the average, and sigma fa, sum of the frequencies below the value of the average. Sigma fb is equal sum of the frequencies above the value of the average, and n is equal sum of the frequencies. Okay, sum of the frequencies, that is number of observations we call them. And with this, okay, we'll do one problem on this. Okay, for this. Calculation of MD with shortcut method. He has given that find out the mean deviation and coefficient deviation from the following data. He has given class 09, 10, 19, 29, 29, 30, 39, 40, 49, and 50, 59. Okay, right. Arithmetic mean we need to find out first. Sigma mf. Okay, in order to find out, he has given class and frequency. We need to find out mid value, and then multiply the mid value with f. Okay, that is mf we need to get, and sigma mf. Here we require sigma mf in order to calculate the x bar. That is equal to arithmetic mean. Uh, Arithmetic mean is equal to okay, x bar is equal to sigma mf by n. Here sigma mf is equal to 6026. Okay, and n is equal to 228. Substituting these values, x bar is equal to 6026 by 228. 26.43 will be the x bar. That is, arithmetic mean is 26.43. Now we need to substitute the same in formula. Sigma mean deviation from mean is equal to the sigma f a m into f a minus sigma m f b, okay, into sigma minus sigma m f b into x bar by n. We know the values. That is, sigma m f a is 4305.5, and sigma mfb is equal to 1720. Okay, 0.5, and sigma fa is equal to 119, sigma fb is equal to 109, and number of observations is 228. X bar we know that 26.43. If we substitute all these in the given formula, we'll get, that is, mdx is equal to 4305.5 minus 1720.5 minus 119 minus 109 into 226.43 by 228. Okay, this is, if you subtract 430 4305.5 minus 1720.5, you will get 2585, minus 119 minus 109, you will get 10 into 26.43. Okay, then 2585 minus 26.43 into 10 is nothing but 264.3. Okay, hence 2585 minus 264.3 by 228. Then you will get 2585 minus 264.3 is equal to 2320.7 by 228, that is 10.18. Now we need to find out coefficient of mean deviation. That is equal to mean deviation of from mean by mean. 10.18 we got mean deviation from mean, and mean is 26.43. Substituting these in coefficient of mean deviation formula, 10.18 by 26.43 is equal to 0.385. Okay, 0.385. As the coefficient of mean deviation is low, the distribution is more consistent and less variable. Right? Now we need to discuss merits of mean deviation. Okay, mean deviation is simple to calculate and easy to understand. As Wessel, Willett, and Simon point out, the outstanding advantage of average deviation is its relative simplicity. Anyone familiar with the concept of average can readily appreciate and meaning of the average deviation. If a situation requires a measure of dispersion that will be presented to the general public or any group not thoroughly grounded, okay, in statistics, the average deviation is very useful. right? Next, second is, since the many deviations taken into consideration, the average of difference most okay of the regularities in the distribution are dispensed with. And third merit is, the computation of mean deviation is based on every item in the distribution, hence it is more representative measure of dispersion than the distance measure like range, quartile deviation, etc. And fourth one, it is very useful in small samples with extreme values as it is least affected by it. Okay, and we have limitations. Limitations of mean deviation. The serious limitation of the mean deviation is that it ignores plus or minus signs while measuring the deviations. Okay, and this prevents further algebraic use of the measure. It studies only the extent of variability but not the direction of variation. And another one is, mean deviation may not give accurate results with any of three averages. Okay, that is mean, median, mode. Though median is considered the appropriate average, it gives unsatisfactory results when the variations are high in the distribution. Mean is also not a correct measure because the sum of deviations ignoring plus or minus signs is higher. Mode is inappropriate because its exact value cannot be always be found. And another limitation is, it is not considered as well defined measure as it alters with different averages, right? With this we conclude mean deviation from mean and median more. Okay, thank you.